Hiya guys, and welcome back to Wade's Workshop. Been a little while, a week or so since I posted anything up. I think maybe a fortnight by the time I get this one out. So it's going to be part 3 of the Quill plate, but fear not, we're going to be getting back and doing some turning work on the lathe, which has been neglected for far too long. It's been all milling machine. Although the lathe will be making parts for the milling machine, another story, but we're going to be doing a bit of turning, so great news there. Okay, a few stickers come in. We'll do our sort of start off with the mail. Stephen Lang at Shark River Machine. We've done a sticker exchange. I don't know if any of you, probably most of you have seen his YouTube channel. So if not, check him out. Okay, bring the sticker to camera. So that's Stephen Lang at Shark River Machine. So check out his channel, guys, if you haven't looked already. And that's going to be going on the sticker board. And secondly, stickers wise, I'll bring this one up. So this is John's workshop. Ground floor on this channel, we'll call it, coming in on the ground floor from the very beginnings. John is an experienced tool maker. He's come along a very similar route to me as we've gone along. Press tools, mostly the same as myself. He's worked for sort of major motor manufacturers, that sort of thing. Right, okay. John, with his experience of tool making, is going to provide us all with a great deal of knowledge, I'm sure, going forward. But at the moment, he's building his workshop, shall we call it. The workshop building is built. It's an old out building, what have you. And he's sort of in the process of cladding it all out, putting in electric, all that sort of thing. He's already got the lathe there doing little projects. But yeah, I mean, great. I'm sure John's going to provide us all with a lot of interesting stuff going forward. So that's John's workshop, and he will be going on the sticker board as well. Final little thing for this episode. I've bought myself, well, a box says centering indicator. I know it as a coaxial. Let me just take that out. Yeah, a coaxial DTI. So I'm sure we're going to see that being used a lot on the milling machine going forward. So that's that. Let's do this little bit of milling, and then we're going to jump on the lathe. Well, I've also taken the corner off here while I was set up as well. So I've just lined up the hole with the depth stop. I actually used a 12mm counterboring bit to line it up. But the diameter of that was a little bit large. So I've gone down to an M10 counterboring bit. And I'm just going to spot face a little face in there. If I just come down and touch, set to 0. Okay. Go gentle with this. Probably 3mm deep. Let me just come to the fine feed wheel for this. It's 2.7, 2.9. That's 3mm. Let's have a look. Yeah, more than enough for a head on the shaft. So, yeah, that's that done. I don't think there's very much to do on this plate at all now. I think we're going to be shifting to the lathe very quickly. So I just thought I'd demonstrate the clock bracket. I might make something for here with a lever or something, but I think it might get in the way of the handle if I do that. But I've always got the 10mm spanner about. It's the one for the draw bolt and what have you. So yeah, I can put a clock rod in here. This might be a bit long at the moment, but you know, I've left it long on the grounds. I can always cut a bit off. And you know, I'm shaking the whole shed there. Yeah, it's just locked solid with the 10mm spanner. I think I may just leave it like that. I don't know. We shall see. You know, you do need to give it a good nip to lock it up, but it does lock up absolutely solid. So that's that part of it. So I want to make some little brass, let's call them nut inserts. And I'm going to screw cut them M12 by 1mm pitch. That should be a bit of fun. So as per usual, I've got a piece of brass bar here, 3/4 brass, just under 19 mil. And I'm just going to chew a piece up. Yeah, a bit more. Oh, let's just get a figure on the end. Probably 30 mil long. Yeah, I'll chew it up 30 mil long. Now the diameter of this brass that I've got isn't big enough to make the little nuts I want. So I'm going to make some nut inserts and perhaps press them into an aluminium ring with a knurl on it. That's 30 mil back. Let's just see what diameter I've come out at. 18.7. Yeah, I think I'll go for 18 mil. So 0.3 aside, 2.25. We'll have another measure. Set a 0 there. That motor on the feed motor does sound a lot louder than it actually is, because it's right underneath the camera there. Okay, that's drilled out 30 mil deep there. At the 10 mil, should be more than enough. I will be running a cut through that to true it up to the outside, and until it's an 11 mil bore. So I had a change of plan and decided to go for the 4 jaw. I'm just going to face off that edge where I parted it. Okay. And again, where I just put a filed chamfer on, I suppose I could just put a brake edge on there, concentric tidy one. That's all it needs. Right. So the next trick is going to be up with a boring bar and bore that to 11 mil. Excuse me, going freehand a minute, guys. 6 mil diameter high-speed steel boring bar, and yeah, boring this out. So I've just had a measure, and go up to my DRO, and I'm around 0.1 tight, so might need another scratch. So yeah, trying not to make you all dizzy here. Trying to hold the camera as steady as I can. I've got the boring bar stuck out probably 2 mil more than it physically needs to be before the part hits the chuck. What am I running at? 1100 RPM. I could probably run a lot faster than that. There we are, disengage speed. Whoop. Got a bit of deflection there, so I'm going to run that cut again and have another measure. Not too bad a finish in there. Okay, little Starrett bore gauges. That's just about perfect. Just measure it with the calipers. I think we'll live with 11 to 11.02. I think we'll get away with that. So, we now have the correct size bore. Screw cutting next. Now, same tool. It's already set center height 60 degrees and square in orientation. So I need to set the gears up in the headstock. We'll disengage the feed motor on the end. And we'll go back to driving by the gearbox. And we'll set up a 1mm pitch. I've just engaged the lead screw. I've locked the chuck. I've rotated the chuck a couple of times. And I've got this jaw here, vertical. If I set a 0 on my DRO and rotate the chuck, 1, 2, 3, and back up to vertical, 1mm on the DRO. Once more, bring that chuck jaw round to vertical, 2mm on the DRO. Round again, 3mm on the DRO. Just idiot proofed that I am on a 1mm pitch. No need to take a scratch pass. I've got a DRO. I can just rotate the chuck one turn with the carriage engaged. The carriage will pull forward by the pitch with every revolution. And yeah, as you can see, take this jaw around, back to vertical, something like that. 4, 5, yeah, and it keeps repeating, as you can see. So yeah, that's the way I check that I'm in the right gear before I even start thinking about cutting the thread. Happy days. So yeah, I'm screw cutting the thread. I'm doing it under power. I've only got about 2mm from when the front of the tool post or the tool holder comes up against the job. So I'm doing it purely by sound. And I'm hitting the stop button the second I hear the sound stop. So I'll just show you. We're running at 140 RPM. Put it in reverse. I'm at 0.45 depth. I wind off to minus 0.3 from my starting position. It's in reverse. Run it out backwards. I'm leaving the lead screw engaged. Yeah, I mean, it's not a great deal to do. It doesn't take that long. Yeah, I'm at 0.45 on depth now. I'm going to go to 0.6 or just over 0.6, 0.62, something like that. But what I am actually doing, stop there, I'm out, back into forward, put the cut back on, and I'm running each cut back to 0.45. I'm running each cut twice to take any spring out, because it is a very weak 5mm diameter boring bar. So in again, fingers on the stop button. Obviously I could do this at about 8 times this speed, but I don't think it would stop quick enough. So this should be the final pass at 0.62 aside. That's the third pass through at that reading. I think I'm going to do one more. I had a quick look at the threads. The threads look about the correct depth, but of course I'm going to make the male thread to match this as a nut. So yeah, I'm just going to run that one more time back into 0.62 there. There's still a bit of spring in there. Once more. Well, as you can see, we're there. The threads look like they're about full depth. Hard to tell. But yeah, M12 by 1. So, I'm just going to break this front edge. And, yep, we're ready to roll. Got a piece of stainless, which is what I'm going to make the screw out of. Yeah, screw cutting in stainless, great fun. Yeah, it's 19 diameter or 3/4, and it's got to be 17 diameter over the length that's sticking out the chuck. So yeah, I'm just taking a 0.1 cut off, so 10 cuts. It's just chewing up at the moment. I got a bit of fluid on it. Yeah, why not? It's going to be 17 over 3mm, right up by the chuck. Then it drops down to 1/2 inch. And then further down towards the end, obviously it's 12mm. And then it'll be a little area about 3mm long with an undercut. So, yeah. I'm just being gentle with this. I'll bring you back when we got the 17 and I'll show you my drawing. So we're nearly there with this diameter now. I've had a re-look at the drawing and the part it's fitting in. The hole in the part that it's fitting, well, the drill I used was 17.5. So yeah, if I aim for under 17mm, I know I'm safe. So if it's 16.98, happy days. If it's 17.1, I'll take another cut. So yeah, I'm not sure exactly where I'm going to be, because I've dropped it and come back. So yeah, I'm just going to carry on here. Again, to my 0 position, right up tight to the chuck. And that will allow me enough of this diameter to part it off later. This bar extends back probably another 7 or 8 inches into the chuck. So we'll have a quick measure there. Again, not critical, as long as it's less than 17. So, oh, let's just wake my calipers up. Check the 0. Yep, fine. 16.8. Right, okay. That's that done. So, because it went away, I lost my 0 on the end. There's my 0 on the end. I'm going to set a 0 on the DRO. And that was 16.8. And I'm looking for 1/2 inch on the next diameter, so that's, we'll call it 12.8, so that's 4. So I need to take 2mm off per side. So let me just, oh, where was I? Let me just do a touch. Okay, I did reset a 0. So I'm going to take 0.2 aside, up to a point. Let me just show the drawing again. Up to a point. There's the 16, but actually 16.8. This is 12.7 or 1/2 inch, and it's 117 from the end. So I've just touched on the end. So I'm going to probably machine back to 116 and somewhere near the 1/2 inch to start with. So yeah, more of the same. Yeah, 0.2 off the diameter. So that's 0.4 off the diameter with every pass. And yeah, away to go. So I'm mixing it up a bit. Decided to take a mil off the diameter in one cut, and just slowed the feed down. And yeah, it seems to cope with that. It's cold. Well, it's lukewarm. So out with a good mic. Where am I going to be fitting it in this area? 12.85. So yeah, I'm going to take another 0.1 off. So that's 0.05 aside. That's there. I'm going to set a 0 on that. And off to go again. Okay, so moment of truth time. 12.699. I think we can live with that. Right. So now I want to leave a portion of this 16mm long at that diameter and undercut a section by 0.1mm. Yeah, 0.1 undersize, so that I haven't got a press fit along the entire length. So yeah, I'm going to just reset my DRO. Dial in 0.05, and I got to go into a length of 111 mil at that. So I shall do that now. Yeah, just 4 thou under. It's fine, it's still over the 12 mil, which is my size that this end's going to be. Happy days. I forgot to turn the camera on, guys, but this area here now, over 72 mil long, is now down to 12 mil. Apologies. I saw where my mistake was. I added up 111 from the end to that point. It should have been 101. But not to worry, I've still got a small area that can be a press fit. So at this intersection here, 72 mil, I need an undercut 1/2 mil deep, which will be the root of the thread. I'm going to come back to about 69 mil perhaps. Somewhere for the thread to run out into. I've just got to a point, I'm a couple of thou off the theoretical depth, and I can start the thread on there, but it doesn't screw on. So okay, so wind off, reverse, come back, have another go. So yeah, a little bit more. I'll probably take another 0.05, something like that. We'll try the fit again. I don't want it sloppy, really. Well, I don't want it sloppy at all. I've had to change the tool. The previous tool just had too big a radius on the end. It wasn't working. It wasn't working for me. So I ground the little tool up at a high-speed steel and refound the groove, which was a bit tricky. Okay, I can't remember what the last cut was. I think it was this reading, so I'm going to run this one again and then put a cut on. No, it wasn't. So right, okay, that's the sour side. I think it was 0.27. I'm on now on 0.3. 0.6 overall depth. Okay, wind off, reverse, back the other way. I'm going to run that cut again. So it was a bit of a challenge, but we've now got a working lead nut or nut on there, adjustable stop nut. There's no backlash, there's no appreciable play, and it runs all the way down to the bottom of the thread. Yeah, I did have to do a bit of hand fitting. I don't think I went deep enough when I machined the nut, so I did have to do a bit of dressing across the surface and, you know, a bit of flanking with a triangular file. But yeah, I mean, I got it in the end, and then a bit of Scotch-Brite over it to make it look nice. And yeah, we now have what will be 2 nuts and the the stop bolt. Final little job. Part it off. Secret with stainless, keep the cut on, don't be afraid of it, just go for it, plenty of fluid to part it off. And there we are. Oh. So I got a piece of aluminium up in the chuck. I'm looking for a diameter of 27 mil finished. It's about 29 now. So I think I'm going to go 28. probably go for 28 mil. I'll skim the OD afterwards. And I want two pieces, 12 mil wide, with a 15 mil reamed hole in the middle. So I'm just going to leave this OD up, and then I'll do the bore. And there's enough on the end of this offcut that I had on this smaller diameter just to do what I'm after. So let's see where I am at the moment. $28.75. Okay, that should do me. Where is my WD-40? Here we are. So that'll leave it in the ballpark at 28 mil. So yeah, 15 mil reamed hole through the middle. I do have a 15 mil reamer, quite a good one. So yeah, I'll be drilling it out, reaming it, and then finishing the OD and parting off two pieces 12 mil thick, or just over 12. Oops. Okay, where are we? Apart from being covered in aluminium, let's have that out of there now. 28.01, we'll live with that. Sometimes you're lucky. Okay, so yeah, I want to drill and ream it about 25 mil deep. It's a 14 mil drill there. I'm going to run a boring bar up it, just to open up to about 14 and a half, 14.7, something like that, and then finish it off with a reamer. So just with a boring bar, opening it up to about 14.7. And yeah, reamer now. So I've got a little setup here. I got my rotary table up on end. Basically turns it into a sort of dividing head, even though it hasn't got the dividing wheels. I've got an ER32 Morse 2 taper up the spout with a drawbar in the rotary table. I've got my two parts here on the end of the shaft that they're going to fit on. I've just got a little adjustable parallel end of the end for support. This piece here is just a spacer to bring me out away from the ER32. And basically what I've decided to do, as these wheels, nuts are a 1 mil pitch, I'm going to put 10 grooves around the circumference, so I know with every groove that I turn them gives me 0.1 in movement along the thread, as it were. So yeah, I'm basically all set up. I'm on the third groove now. I've got a ball end cutter in here, and I'm just machining the little grooves. You can't really see much of the ones I've already done from that angle. I'll bring you around the other side. I'm basically going into a depth of 1.4 millimeters. And I'm machining a scallop out of the circumference of the aluminium ring. Obviously the brass lead nut is press fitted inside the aluminium ring. You can see the brass here. They're press fitted into the two rings. Yeah, in an ideal world I'd have had some larger diameter brass and made them out of brass completely. But I didn't have any brass that size. So no worries, we'll do it this way. So yeah, you can see the previous two grooves These are just screwed on tightly. And I'm going into a depth of 1.4 millimeters. No maths or physics behind that. I started the first one, took a look, and when I got down to 1.4 mil deep, I thought that looks about right. But yeah, the 10 grooves will give me 0.1 movement of the thread of the nut up and down the shaft with every groove, with it being a 1 mil pitch. On the final tub. And there we are. Okie dokie. How long did that take? Probably about 45 minutes, I expect, to do the lot. But happy days. Yeah. A lot of deburring to do now, I suspect. So I've removed the old guard bracket from here to get it out of the way. There's a little micro switch in here. Okay, let me just pull it out. Which had two cables going onto it. And basically, if you take the cables off here, it breaks the circuit. Because this is a normally closed switch, and when you push the button, it makes it open circuit between the two wires, the way it's been wired. So if you just simply remove the two wires and tuck them back inside, the miller won't start. It's going to think that you've opened the guard. So yeah, simply I put a little loop with a couple of male spade connectors, insulated it all, and tucked it back inside where it goes. Absolutely fine. So I've now got access to this area. Now the shaft we made earlier is going to push up through here, and it's going to be a press fit on that last section, and it'll push back up into there. I'm not going to press it in at this stage. So what I'm going to need is a block on here. I'm going to utilize one of the existing holes from the limit switch, or the guard. And I cut myself a little block of aluminium. I'm going to make it flush on the back of there. I'll probably replicate this angle on the front of it. It's going to sit up on here. So I'll have to pick up a hole distance from the back to that one. Find a hole position in here. It's going to have to be quite close in to where the bar is, but I can find a hole position in here. And drill and tap a new hole in the head casting, and then pick up a center where the existing hole is. I might have might bolt it on first, put a little transfer punch up, something like that. Might have to turn one up for the right size. I've got metric ones, but that's 1/2 inch. Anyway, so yeah, that's where we go next. So I'm going to start blocking up this block. So I bolted it on with the one bolt. Looked at where I can put the second hole, and I thought, well, in the front here the casting's about 3/4 thick, but this sidewall is only about 6 mil thick, the casting up through here, maybe 5-6 mil. So I want to come back out onto the front edge here where there's a bit more meat in the casting. So I've put a centre line on this way and come back pretty much halfway in through the thick part, which is 8 mil. So I've marked a line, scribed a line, 2 lines there. So yeah, I'm basically going to repeat the operation and drill the holes through there now, and then use the holes as a guide for tapping. So I've made a little transfer punch that just slips up through that 1/2 inch reamed hole with a pointer on the end. And it was the only piece of material I had that was already the right diameter. So I just got a little centre pop here and up through that hole. And hopefully you should be able to see. Yep, that's centre punched the underside of that. So that gives me a reference point for the hole that's got to go in it. I think I'm going to put a brass bush in this down from the top. And probably going to machine a few mil off the top of this as well. I'm going to put a brass bush through here so that when the rod's going up and down, it's not you know, never going to touch the aluminium anyway, but so that it's a nice slip fit through the brass bush. Keeps it nice and solid. And yeah, where the nuts come down, you know, when I bottom out then, you know, if you can imagine I pulling down, I bottom out, I'm not bottoming the brass out on this soft aluminium, I'll be bottoming out on a piece of brass. So that's the plan. So I've got a little bush, and I'm just going to press that in there, or squeeze it in. It is a good fit. And it should be sticking up about 0.2 above this surface, which it is, and just be about flush with that surface, which it is. Okay, so that's now got its bush in, and when these come down, they're going to hit, you know, when I pull down, it's going to hit pretty much on the brass, and it can't push the brass out. And much the same with these, it can't push the brass out because it's pushing, you know, in the direction of load. So they're headed in the direction of load. Okay, we're really getting there now. So I've just been editing this particular video that you've just watched, and I know it's a bit of a long one, guys, and then realised I haven't got any footage of the finished unit. So yeah, basically there's the stop. It's adjustable. It was mentioned to me, I think, way back when I put 0.1 up, to use the old squeeze nuts that you can squeeze, drop, you know, and quick move job. Don't think I really got room for them, and it's not a huge distance that I'm travelling here. Not like on a Bridgeport where you're having to wind down for 6 inches or whatever. We've only got sort of 55 mil of travel here. But yeah, the brass bush is in. The two fancy little nuts that we made, M12 by 1. Yeah, and it, as you can see, to adjust the pair of them away, I could just put my hand across them, lock them in any position. And of course we know that every time I come, either between a high point and a low point, is 0.1 movement. So yeah, I'm happy with how this bit turned out. Well, there we are, guys. I think that's about enough for this video, don't you? It's going to be quite long, and it's going to take an age to upload. Anyway, it was nice to jump back on the lathe for a change. I'm happy how it turned out. So there's a little bit more to do. I need to sort out the DTI stand that's going to go in the other side. I've got a few bits of it. I need to make a few more parts to get the DTI fitted. So I've got a dedicated one for the mill. Anyway, thanks for watching, guys. Thanks for subscribing, and we'll see you all very soon. Cheers now.